Welcome back to Mathematics Lifeline. In today's video, I want to go over how we can prove the quadratic formula for solving for the solutions for x in a quadratic equation. Now, I'm venturing to say that probably 99% of you watching this video have at least seen the quadratic formula before. And you know that it's a very useful trick, but how can we prove this for all polynomials of degree 2 with these a, b, and c coefficients? So the first thing we're going to do is we're going to divide every single term in here by a. So if we do that, we're going to end up with x squared plus b over ax plus c over a equals 0. Now the reason we're doing that is because what we're going to want to do is we're going to want to complete the square. So to do that, we're going to try to make these two terms, we're going to try to add something to it that will end up making it a perfect square. So before we do that, we're going to move this c over a to this side. So we'll have x squared plus b over a x equals negative c over a. So we're going to take this right here and complete the square. Now, if you're not familiar with completing the square, what we do is we divide this b term, or the term in front of the x, we're going to divide it by 2, and then we square it. And whatever that is, we add it on to this side of the equation. So when we do that, we're going to divide this by 2. And when we divide by 2, we're multiplying by 1/2, so we're going to get b over 2a. And then when we square that, we're going to get b squared over 4a squared. So when we complete the square, we're going to get x squared plus b over ax plus b squared over 4a squared. And that equals minus c over a. But what we're going to do is we are going to have to add over this b squared over 4a squared because we added it to this side, so we need to add it to this side. So we're going to add a b squared over 4a squared. Okay, so now what we're going to do is we have this side, which we said was a perfect square now. And that's true because we could write this left side as x plus b over 2a all squared. If you were to FOIL this out, you would actually get what we have right here. So that is the square version, the perfect square version of doing this process. That's why we had to complete the square, was so we could write it like this. Now this is equal to, on the right, we're going to want to try to combine these into one fraction. So in this case, we have minus c over a plus b squared over 4a squared. Well, in order to add these fractions, we need the same denominator. And we're missing a factor of 4a from this denominator. So we need to multiply the numerator and denominator by 4a. So we'll get a minus 4ac all over 4a squared plus the b squared over 4a squared. Now you'll notice the b squared and the minus 4ac are in the quadratic formula, so let's go ahead and just write it in that form. So we have b squared minus 4ac all over 4a squared. So that's what we've simplified the right side down to. So now remember, we have x plus b over 2a all squared is equal to this. So if we're going to solve for x, we need to take the square root of both sides. So we're going to take the square root of this side, and since it's squared, we can just write down what's inside of the squared part, which is going to be x plus b over 2a. Now on this side, we're going to take the square root of everything, but there's nothing that is inherently squared in the numerator. So that's going to go under a square root. This one right here is a perfect square. So we have this equal to plus or minus the square root of b squared minus 4ac in the numerator, right? Because there's nothing squared here, so we need that plus or minus. In the denominator, we have the square root of 4a squared. Well, the square root of 4a squared is going to be just 2a. So this is what we've converted the right side into. Now to solve for x, all we need to do is subtract this b over 2a over to this side. And there's no issue with this because they have the same denominator. So when we subtract it over, I'm going to put it in front to match the formula. But we'll get an x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And of course, because of the same denominator, we can write this as negative b plus or minus the square root of b squared minus 4ac all over 2a. And that is the quadratic formula. We are done. That's our proof. So you can see that this proof really isn't that advanced. This only uses topics from your algebra classes. Maybe college algebra with this completing the square part, but completing the square is not all that tough. It just looks harder because we have all these unknowns. But we were able to get right back to this quadratic formula, and all we did was complete the square and just do some basic algebra with it. So I think this is a really cool proof. Obviously, we know how useful the quadratic formula is, so hopefully this gave you some insight into how this was originally come up with in the first place. But yeah, if you have any questions, feel free to let me know in the comments. I'll get back to you if I can. But if not, then I will see you in the next video. Thanks for watching.